Okay, hello everyone. Yes, as John mentioned, as you can see as well, I work for BRE, and you would expect maybe to speak about BREEAM, but it's actually Well I'm going to talk to you about today. We are actually talking to IWBI about Well and BREEAM. You may have read about the crosswalk that was done recently. So there are some aspects of BREEAM that are found in Well and vice versa. Well, the Wellbeing standard is, as I'm sure you are becoming more and more aware, is growing worldwide, and I think the main reason for that is that it addresses our health and well-being, which is becoming again a focus in building design. The presentation today focuses on the daylight requirements, but before we do that, I'm just going to talk a bit to give you an introduction on the Wellbeing standard overall. V1, so this is the first version of the standard. The second version of the standard is planned for release some point this year. And then we'll have a look at all the light features, all the features in the light concept as it's called, before moving on to the daylight requirements, which we'll have a look at through this worked example of an office space, before drawing some conclusions in the end. So first about the Wellbeing standard. The first version of the standard was released in 2014, so it's almost 4 years, actually 3 years and 3.5 years now. And it was the first standard, the first building standard worldwide that focused exclusively on the health and well-being of occupants. And it started to do that by implementing strategies and performance targets for building design that were meant to improve occupants' mood, fitness, comfort, performance, health. So all sorts of things that weren't addressed to this amount of detail before. And again, it addresses a number of wellness concepts, as they are called. It's basically, there are sections within the Wellbeing standard that are named after each concept. And you can see here all the concepts, the wellness concepts in the Wellbeing standard. And these are starting from left, top left: air, water, nourishment, light, fitness, comfort, mind, and more recently innovation. This wasn't a concept per se in previous versions, if you wish, of the standard. I'm saying that versions is not really accurate because it's the same version 1. But what the standard does is every 3 months they release these quarterly updates, and so 4 times a year you get updates to this version of the standard. And there's been some changes already in the standard. The last version is this one, version 1, with Q1 2018 addenda. And again, as I said, these changes are ongoing. Then all these concepts are divided into features. These features giving requirements for increasing health, well-being, and comfort of occupants. By imposing these requirements in 2 forms. You can have, and there are preconditions, which are basically mandatory, so they have to be met for all levels of certification, and optimizations, which introduce optional technologies, strategies, or design protocols. Here you can see a table showing the 3 levels of certification that are available within the version 1 of the standard. As you can see, for silver, you have to comply with the preconditions, all of them, and you don't have to comply with any of the optimizations, although you may already do that. If you comply with, obviously, all preconditions and with at least 40% of the optimizations, you can get a gold certification. If you comply with at least 80% of the optimizations, you get a platinum. Again, you have to comply with all the preconditions. One precondition failed, no certification at all. And this is how the score is calculated to get to achieve WELL certification. As mentioned already, preconditions, all of them have to be met. And once this is achieved, you work out a score using this formula, which gives a score depending on the number or the proportion of optimizations achieved from the total that are available. And then depending on the number you get, which is actually, the score is rounded down to the nearest whole number. If you get 5 or 6, you get silver. If you get 5 or 8, you get gold. And 9 or 10 is platinum. So this is how the score is calculated. And in the end, you get this WELL scorecard, which shows the scores for each individual concept and the overall level of certification. In this case, this example is showing you a gold certification. You don't see the scores for each concept, but that's fine. This slide is showing you the structure of the WELL light concept. So the fourth concept within the building standard, the Wellbeing Standard, is a light concept, which consists of 11 features. 4 of these 11 features are preconditions, so they are mandatory and have to be met. The ones shown in darker colors on this slide. And the other 7 features in lighter colors are optimizations. You don't have to meet them, but if you meet them, you get a high score. And all these features address both daylight, which is shown in blue. So the blue color means that that particular feature addresses or includes references to daylight. Electric light shown in orange, and also surface finishes in yellow. So it's that feature, one feature, surface design. And they are numbered 53 to 63 purely because there are other features before and after. So it's all numbered in sequence throughout the whole building standard, going through all of the concepts. This is in version 1. These are the verification methods for light. And before discussing specifically about them, it may be helpful to mention that in order to get a WELL certification, there is an assessment process going on, which mainly consists of 2 big stages. One of them is called documentation review, and another one is called performance verification. Documentation review is that stage where the building design is verified by submitting a number of documents, as the name implies, whereas performance verification is supposed to verify that the building is performing as it was designed to perform. And that entails a number of assessments, on-site assessments, that may be, as we'll see in the next slides, more or less difficult to achieve. Going back to the light concept, these are the verification methods, as I said. Letters of assurance, these can be issued by the architect or the map engineer, confirming different things. Annotated documents, which can be policy documents, professional narratives, modeling reports, and architectural drawings, again confirming certain things required by the various features. And the last one here, on-site assessment methods, which can be of 3 types: spot measurements, spot checks, and visual inspections. You see those 3 symbols, the colored symbols over there. I use them for easier identification in the next slides of each of these on-site assessment methods. So wherever you'll see later in the requirements, say the red one, if you could just remember that that is verified in situ by spot measurement, and the same for the other 2. Basically, all the features in the standard, because they have different requirements, can be verified through documentation review, performance verification, or a combination of both. So it's quite a complex process going on. Right, now we're going to move into the WELL light concept and we look at each feature in some more detail. This is the first one, feature 53, visual lighting design, which again is a precondition that has to be met for WELL certification. And this is basically aimed at providing lighting that gives basic visual comfort for the occupants of the space. And the requirements include this average horizontally luminance from the electric lighting system, so from the ambient lighting of at least 215 lux as measured on the horizontal working plane at 0.76 meters above the floor, with additional task lighting going up to 300 to 500 lux upon request. And it also requires that the lighting system is zoned into independently controlled groups. So I won't spend too much on these slides referring to electric lighting purely because we are supposed to talk about daylight, but I'm just going through the slides just to give you an overview of the light concept. There is another requirement for strategies to be in place in order to control the luminous distribution inside this one space and between spaces. For example, this is in the form of maximum luminous ratios, 3:1 between a task area and adjacent areas, immediately adjacent areas, and 10:1, for example, between the main space and ancillary rooms, 10:1 again between maximum and minimum ceiling luminance, and another 10:1 between the task area and remote non-adjacent surfaces or areas in the space.
Cosmin, can you specify whether that's horizontal or vertical as well in terms of contrast?
It's horizontal. That's horizontal, yes. Vertical is taken into account into this feature, which is the circadian lighting design feature 54, which again is a precondition that covers both electric and daylight. I mean, there is some reference to daylight. This is probably, if you are aware of the Wellbeing standard, the most difficult feature to achieve in typical applications. And it aims at minimizing disruption to the human circadian system. That's the main objective of this feature. And it does that by giving requirements in two forms. There are basically two alternative criteria that can be looked at. And the first one, again, that red sign, so this means it has to be measured in situ, which again may be a challenge. Nevertheless, the requirement says you have to have at least 200 EML, and I'm going to explain in a second what that means, from electric lighting and daylight. So in other words, daylight can be included within this value, between the hours, at least between the hours of 9 until 1 o'clock for every day of the year. And this value is measured in a vertical plane at 1.2 meters from the floor level in the main direction of view of the occupant, so facing forward. That's the requirement. The second one, the second criterion, which again is an alternative to that, is to have 150 equivalent melanopic lux EML from electric lighting alone, so no daylight, just from electric lighting. And that has to be, I should have mentioned for the first one, that 200 EML should be achieved at least 75% of the workstations, whereas the second one, 150 EML from electric lighting, has to be met at all workstations. And there is no mention of time, but that's what the electric lighting system should give. Now, going back to EML, this is equivalent melanopic lux. It's a metric that was introduced by the Wellbeing Standard based on the research done by Lucas et al. At Manchester University back in 2014, where they derived equivalent lux levels for different types of photoreceptor in the eye. The melanopic channel being one of them. So we have these 5 types of cells in the eye, and the EML was tailored, or was developed to take into account the spectral response of the melanopsin containing IPRGC, so the cells in the eye that are responsible, that help control the daily body rhythms. Lucas et al. Introduced the concept, but then the Wellbeing Standard introduced the value of, it was initially 250, but it was decreased about a year ago or so to 200 EML. This value of equivalent melanopic lux can be calculated using a method that is given in the standard to calculate the R value in this formula, which is the melanopic ratio, which depends on the spectral power distribution of the light incident at the measurement point. And if you can calculate the melanopic ratio, again based on the spectral power distribution readings, you multiply that by the lux value that is measured with a lux meter at the measurement point, and then you can calculate the EML value. So this means you have, if you want to verify this feature in situ, you have to go in situ and measure the illuminance and the spectral power distribution at that point, 1.2 meter above the floor level, facing forward, for each desk, and see how many desks achieve this criterion. You can also work out the other way around. So starting from 200 EML and looking at and knowing the melanopic ratio for the typical light sources based on their spectral power distribution, you can work out the lux value, which corresponds to 200 EML for typical light sources. And this diagram here shows exactly that. So you can see that 200 EML is equivalent to 180 lux for fluorescent 7500 Kelvin to 444 lux for LED 2700 Kelvin. It's just obviously some examples. If you have other conditions in the space, you may get different values. But this is just to show you what the vertical illuminance, photopic illuminance, should be in lux to match that requirement of 200 EML. The same for 150 EML, which is obviously lower. It goes from 135 to 333, depending on the spectrum. These are the values. We may ask ourselves, is this difficult to meet? Is it easy? Is this too much? Is it too low? If we just refer now to BSE and 12464 part 1, there is a recommendation in there about a minimum mean cylindrical illuminance of 50 lux at 1.2 meters from the floor for sitting occupants. And if you compare 50 to these values, you can get an idea that it may be difficult using common artificial lighting practice to meet these requirements, unless you have sufficient amounts of daylight to achieve this criterion. Other circadian lighting metrics have been proposed by others. This slide is showing some information about the melanopic daylight equivalent illuminance, MDEI, in short. This was introduced about 2 years ago by this German standard DIN spec 5031-100, and there was also this accelerated report dated again 2016, which improved the Lucas method, the toolkit developed by Lucas previously 2 years ago, the one that I mentioned earlier, to match the CIE recommendations for SI units, just to comply to match the units to the international system. And they introduced what's called alpha opic irradiances for each of the 5 channels for the photoreceptors in the eye. And also daylight illuminance, melanopic daylight equivalent illuminance, or alpha opic daylight equivalent illuminance is for each of the 5 channels. But if you again refer to melanopic, which is the link to melanopsin containing IPRGCs in the eye, so the cells again that help control the daily body rhythms, we refer to them by using the term melanopic. And this melanopic daylight equivalent illuminance was defined as being the amount of daylight illuminance that is necessary to produce a similar stimulation of the melanopic channel, those cells in the eye, as the eye source that is considered. So for example, if you look at, but we'll go this actually through this in this diagram here. We'll just keep that in mind for the moment. And then there was another German standard, DIN spec 67600, which came up with a recommendation for circadian lighting. It's actually biologically effective lighting. That's the term that is addressed by this standard, biological effective lighting. And this standard recommends 250 lux at 8,000 Kelvin at the eye for several hours, preferably in the morning. This is the recommendation. And they also give a method to calculate equivalent values for different spectra by using the so-called melanopic action factors, which can be again calculated based on the spectral power distribution readings, something similar to the AML method. So you read the spectral power distribution, you also read the visual lux value, and then you can work out the MDI. And going back to this recommendation of 250 lux at 8,000 Kelvin, this is equivalent to 239 lux for daylight 6,500 K, so D65.
So daylight in the morning, you're saying that we have 6,500 Kelvin with daylight.
No, sorry, I'm not saying that, because the spectrum is different throughout the day. I'm saying that 239 lux from the CIE standard daylight illuminant, so D65, that's what it would need to give to get that value. So 239 lux from D65 would be needed to achieve 250 lux at 8,000 Kelvin.
So how would you do a lighting design to achieve 250 lux at 8,000 Kelvin? Would you have different lamp sources in the building that, with artificial lighting, that give you those 8,000 Kelvin in the morning and then different Kelvins during the day? Or
you don't have to get that color temperature in the space. No, because for example, the values I'm showing here in this diagram, you see, for example, if you have an LED, a warm white LED of about 3,000 Kelvin, the equivalent value to 239 MDEI is 560 lux. That's visual lux. I'm sorry?
you have to increase the light level.
In this case, yes. So if you were to use warm white LEDs like that, with this spectrum, you would need to have 560 visual lux to get a melanopic daylight equivalent illuminance of 239 lux at that point. So it's a matter of playing with the light levels depending on the spectrum.
Sorry to add something extra to it, but none of the LED light sources here are standards. So that whilst they have a headline Kelvin temperature, color temperature, their spectra could vary substantially.
Yes, you're right, yes.
So that using this number has to be done with reference, if I may.
Yes.
Sorry to be
No,
picky
you're
about
very,
things.
very correct. This is right. And obviously, this I should have written. These examples are taken from the German standard. So this is the reference for this diagram, the German standard. Yes, I apologize for that. You're right. So it's perfectly true that LEDs of the same color temperature may have different spectra, and then you will need to work out the melanopic action factor for those light sources, and then work out how much light you need from those to get this requirement. But again, if you look at the values, they are very, very high in terms of visual lux. So again, the whole design strategy may need to be different.
Can you just give everyone a plug-in sleep lamp, tell them to put it on between 9 and 12?
Well, this could be an option. I mean, obviously it depends on on the design of the space. But one way around it is to have something like they said in feature 53, where you have the ambient lighting system giving you a certain, in this case, 215 lux, and then adding task lighting to increase that illuminance to 300 to 500 lux, visual lux on the horizontal. But then something similar could be used for this requirement as well.
Because there is a sustainability narrative which says the original lighting standards for offices, for example, was set by people selling electricity, not people looking at light. And that I've been to seminars of sustainable buildings where the lighting level is surprisingly low, and the idea is light the task, not the room, and this starts to look like heading off in the opposite direction.
Yes, yes, in a way it does. Because obviously the standards that we are using in common artificial lighting practice are basically based on non-circadian visual tasks. So this may be something different. But what we believe at BRE is that more research is needed. Because obviously you came up with these figures, there isn't much research behind those figures as far as we can see it. And you have to back up all these requirements, all these criteria with evidence-based research in real applications.
Well, we have to face the fact that even 250 lux is effectively twilight. And that's what we actually, I hate to say the word, we condemn everybody to permanent twilight in buildings. Things. And it's interesting, I suspect, I know what others have observed, is that there is pressure now to raise light levels in buildings again, quite substantially. Because that's the only way of meeting something close to our sort of evolutionary state which we would have outside.
I believe there might be a way around that by not necessarily increasing the light levels, but playing with a spectrum. So by giving a specific spectrum of light for a certain duration at the right time of day, you may not need to increase the light levels to that extent. But again, I think more research is needed to back up all this.
Just a quick comment on that is in a project I'm aware of recently, this one was made by having all the monitors switched on, and now there's allowance for the screen light to be included into the dynamic lux.
Okay, yeah, that can be included.
Quite a lot, and possibly there would be products coming in which just basically cover for this particular requirement, so you wouldn't have to design everything to be everywhere that high.
Okay. Yes, as far as I'm aware, the Wellbeing standard allows inclusion of contribution from computer screens, so that may increase the levels a bit. But not so much, it depends on the screens and the space, and there is some. Okay, I'm going now to this slide. I won't spend too long on this because Andrew will also be talking about circadian stimulus and also EML. This is just to show you that there is another metric available. This was developed by researchers at the Lighting Research Center at Rensselaer Polytechnic Institute in the US. And they came up with this metric just to bring all the channels, if you wish, together by defining circadian stimulus, CS, as the effectiveness of spectrally weighted irradiance at the eye, which is specific to the human circadian system, that is measured by acute nocturnal melatonin suppression after 1 hour exposure. It's basically it's a metric in relative units, so it ranges from 0.1 to 0.7. That's the maximum value of it, and it takes into account again the spectrum of incident light and the amount of light at that point. It's a different way of putting things into a metric, and the recommendation of these researchers in order to have an effective circadian entrainment is to have at least 0.3 circadian stimulus at the eye for at least 1 hour in the early part of the day. Again, this can be calculated. Andrew will show you in the next presentation how to do that. But if you work out the equivalent values for CS 0.3 for different light spectra, you would arrive at these values. So daylight 6,500 Kelvin is 180, that's visual lux. And if you go back to this figure here for daylight 6,500 Kelvin of 182 for 200 EML, so it's almost there. It's actually exactly there with the fluorescent 7,500. But what I mean is CS 0.3 is almost equivalent to EML 200. But then if you look at blue LED, blue light, and red light, you have this tremendous difference between them. So to get that stimulation, circadian stimulation, you'd only need 17 lux of blue light at the eye, but you would need 37,500 lux from a red light red LED. Again, the spectrum is the reason for that. Okay, we are now moving on to the other features. As I said, Andrew will be talking in a bit more detail about the circadian aspect. Feature 55, electric light glare control, again deals with electric lighting, is a precondition that has to be met, and it basically imposes limits for lamp and luminance, and it also gives shielding angles for lamps of a specific luminance. So it's not very complicated. It may be complicated to assess, but there is also an alternative adherence path which is accepted by the Wellbeing standard, that is the UGR criteria. So if a space already complies with the UGR criteria as set out by the EN 12464 Part 1 standard, then that's fine. It's already complied with this feature, this well feature as well. Features 56, solar glare control, is the last precondition. So again, this has also this has to be met as well, and it deals with, as its names imply, reducing glare from incoming sunlight, and this is done through different requirements that are applicable to two broad types of windows, and the Wellbeing standard defines view windows as those windows that are not more than 2.1 meters above the floor, and daylight management, or windows for daylight management, the other ones that are above 2.1 meters from the floor. And they give these options for the different types of window. You can see the options there, so you can use blinds or internal shading devices with manual or time-based controls, or external shading, or glazing with variable transmission, and the transmittance has to be reduced, has to be able to go down by at least 90%. And these are the options for view windows and also for the other ones. But in addition, for daylight management, you also get the option of using light shelves or films that reflect sunlight towards the ceiling. Not all of them have to be met, but at least one of them has to be met. For atria, there is an alternative criterion saying that a combination of these has to be used. So glare-reducing film with solar transmittance less than 10%. Workstations, they have to be set back from atria by at least 7 feet. And also building orientation would need to be used in order to prevent or reduce glare from sunlight.
Could I just ask, is there any recognition of the fact that when you use blinds, you remove the doors and windows?
Sorry, you remove the windows? Oh, yes.
Yes. Because at the moment, with most rating systems, you get both credits when they cancel each other out effectively.
Yes, I agree with that. And well, the point is about controls. You know, it matters how you control them. So here you get blinds or internal shading, so let's say blinds with manual or time-based controls. But there is another requirement, we'll see later, on automatic controls for shading, which again is not really the best option, isn't it? Because you take away you know, the ability of occupants to control the space as they wish. But
just windows or also roof lights?
Sorry, which one? The blinds or the automatic controls?
For windows, it's just vertical windows.
These are vertical windows.
Just vertical, not
Yeah.
horizontal.
So yeah, I agree.
I think you should have manual control so you can pull it down and then they automatically go back up, because once somebody's pulled the blind down because it's on their screen, it then stays down for 3 days because they can't be asked to walk over and put it back up.
I think this is a very common issue, isn't it, in most office spaces? But even some people may have different preferences. Some they may just close them, or others just raise them. So yeah, it's a complex variable, you know, in a space indeed. Features 57 is the first optimization, and it deals with glare from windows, but also from the electric lighting. What it basically requires is that computer screens that are located within 4.5 meters of view windows, they have to be oriented within a 20 degrees angle perpendicular to the plane of the nearest window. That's the requirement. The overhead luminaires must not be directly aimed at computer screens. That's the requirement. And there is also an alternative that the Wellbeing standard accepts by using computer screens that have adjustable arms or stands with adjustable arms. Feature 58, color quality, applies to electric lighting. Again, optimization, CRI above 80. This is obviously very common in common artificial lighting practice already. However, the Wellbeing standard in this feature also introduces a minimum R9 figure, the specific color rendering index for red colors of 50. And this may be an issue because not so many manufacturers may report or provide products with an R9 value of at least 50. For transient areas, there is an alternative path by allowing a minimum R9 value of 15, but they require CRI above 85 in those areas.
Can we also note that if you've got an R9 of 50 or plus, your CRI is likely to be rather higher than 80?
Yes.
So it's a sort of slightly nonsense requirement. It's sort of
Yes.
tail wagging the dog, if I can put it that way.
Yes. So yeah, if you had the second one, you might have the first one already. But okay, the next one is feature 59, surface design, which is an optimization that deals with surface finishes. And it basically sets minimum reflectance values for the different surfaces inside the space, something like the European standard for lighting does already, or this SLL code for lighting. But the values are different, and also slightly the strategy is different by only looking at ceilings, vertical surfaces, which include walls, but not only walls, it can be other vertical surfaces as well, and furniture. There is no requirement for floors in the Wellbeing standard. And also the different perspective is by, if you look at the percentage of areas that have to comply with these requirements. The minimum values of 0.8, 0.7 and 0.5 for ceilings, vertical surfaces and furniture apply to different proportions of the area of these surfaces that is directly visible from regularly occupied spaces. So that's the area in that table.
Does that give the office police a stick to beat you with on tidy desk rules?
Well, I can't comment on that, but it depends what you have on your desk. If you have white stuff,
I think it's generally known as,
then
generally known as a midden, but it is mainly white.
yeah. Well, if you have white objects,
so if anyone
then
challenges me, I can point out it is white.
yes, you may be fine with that if it's white objects. Feature 60, automated shading and dimming controls. Again, another optimization dealing with automatic controls for shading. And this applies for windows that are larger than 0.55 square meters, but also automatic controls for dimming the electric lighting. And this has to be done continuously in response to daylight, and also dimming to 20% or less, or switch off in unoccupied areas. And again, the mention I made earlier about automatic controls for shading may be an issue because you would take away the capacity for users to control the environment as they wish.
Does that include variable transmission glazing?
No, this is for shading. As far as I remember, it may not include actually. I'm not sure, John.
Right.
I need to double check, but I believe it's just.
On an earlier slide, variable transmission glazing was mentioned.
Yes, this was sorry.
Maybe it was for a different.
That one.
Yeah.
This one.
Yeah.
This has to be. I mean, not exactly that, but that's an option that has to be in place.
Yeah.
But there isn't actually a mention about how you control that specifically. If that's the question, because you're asking about.
Well, soul control is part of it as well.
Yeah.
ask with the shading? It's possible to design a shading system that doesn't need to move, that will shade the windows of the end. So would you not get that credit if you design a series of louvers that don't have to have motors?
It's a good question.
The spacing on that doesn't look like it's got motors in it. The spacing kind of does. But if you continued that all the way down the window, you wouldn't need to put motors in.
Yeah, that's a very good question. I believe, because this is optimization, is not very critical if you don't meet it. Yeah. But I think that there must be a mention if that's the case. I can't really tell you the precise answer at the moment. I need to have a look into the standard. But as far as I remember, I haven't come across that. Right, 61, right to light. It's not very difficult to check. This basically tries to encourage adequate exposure to natural light within buildings by giving these maximum distances between view windows or atria in some cases and workstations. So it's just set out a proportion of the a percentage of the regularly occupied areas or workstations that have to be within those distances of view windows. Another feature, which again is on optimization, trying to, again, encouraging exposure to adequate levels of daylight in internal spaces, is this one, feature 62 daylight modeling, which sets criteria for spatial daylight autonomy and annual sunlight exposure, saying that at least 55% of a regularly occupied space has to achieve at least 300 lux from daylight for at least 50% of the working hours, and also that not more than 10% of the same regularly occupied space receives no more than 1,000 lux from daylight over 250 hours in a year. This is some.
I have a question about this. Because we have been doing some education buildings and classrooms, like one story with roof lights, with prismatic daylighting. And with our products, we don't provide any glare, but in the winter months, we can get 300 lux with very good uniformity only with prismatic daylighting. But in the summer, obviously, the light level is going to go up. And sometimes we get over 1,000 lux. In most of the buildings, we will get over 1,000 lux, but it's completely diffuse light. What's wrong with doing that? And we will achieve very good uniformity. I just think this is not quite right, because if you want to try to get a very good daylight level with good uniformity, obviously in the summer months you will increase that light level. It's
yes.
Kind of contradictory.
That's direct sun. That's supposed to be direct sun, isn't it? 1,000 lux.
Well, it's supposed to be, and I think the modeling should take that into account, I believe.
And perhaps it's worth saying that comes from LM83 in the States, and actually not many people believe that at all. Actually, the methodology that resulted in it is very shaky.
Yeah.
Well, in LEED, it's used as a proxy for daylight glare rather than sunlight.
It is indeed. And that's why they kind of gave this alternative criteria. So if you comply with LEED, you comply with this as well. Yes, I mean, the intention was to also minimize heat gains. But again, if you do it...
But for example, I can do a design with only a couple of products and provide in a room like this 80 or more uniformity with hardly any heat gain, because the product has a very low solar heat gain, but has got 81% light transmission and 100% diffusion. And in opens with prismatic daylighting, you get very good uniformity. But as I said, you will get much more than 1,000 lux in the summer months, but you don't really notice it because it's all diffuse. The light is all diffuse. So I think when I see that, I just don't agree with it. I just don't think that's going to work.
Well, I think obviously this is something that it's worth obviously talking to them, because I think although they gave this criteria, I think it's possible to talk on, you know, on a project by project basis about the different things, the details around it.
It's a specular transmission through glazing, yes.
Yes.
So if you use other types of glazing, that's not going to work.
Yes, you're right.
Excuse me, one thing I found also on single-storey educational buildings with roof lights is, yes, you can pass the plant-based daylight modeling calculations, but you know, when you come around London or to the southeast or southwest, you'll fail on TM52 calculations unless you have internal blinds or some form of circadian. And when I mean in the modelling, you've got to take into account that the heat is absorbed in the blinds and then vented out through an opening roof light. Otherwise, you'll fail because of the high occupancy gains that you have to assume in education.
Yeah, no, this is true. Okay, so if we just move on to the last feature, which is again an optimization working on daylight just to improve the daylight quantity and quality, and also minimize heat gains. The requirements are in this form, so they give this range of window to wall ratios between 20 and 60%, and they also require that external shading or adjustable opacity glazing is used for those windows for which the window to wall ratio is about 40%. But another requirement is this: 40 to 60% of window area has to be at least 2.1 meters above the floor. This is more geometric. If we go now to transmittance, the requirements say that you have to have a minimum visible light transmittance of 0.6 for windows that are above 2.1 meters from the floor. Skylights are excluded, and also at least 0.5 for windows that are below 2.1 meters above the floor. There is also a requirement about uniformity, so uniform color transmittance. The visible light transmittance should not vary by a factor, by more than a factor of 2 within this wavelengths range, so 400 to 650 nanometers.
So what's the 2.1 meters above the floor about?
Yes, I think this is the way the Well standard or these light features were conceived. There was the intention to divide the window wall into two areas. So the one below 2.1 for view out, and above 2.1 for daylight management, as it's called. But
it's also to discourage against glazing below cell height, isn't it?
Yes. This is of course, yes. Yeah. And obviously in common practice, almost half of the window area being at 2.1 or above 2.1 is not really common. So this may be a problem. And actually the example I'm going to show you in the next slides will come across that exactly. Okay, so this is the kind of the last part of the presentation, dealing with an example, a worked example of an office space. This is the office space we are going to use to go through just the daylight features, the features in the Wellbeing Standard that relate to daylight, not all of them, just those on daylight. The office space, as you can see in this image, also on the layout on the right-hand side, has windows on 3 walls, 3 facades facing north, west, and south. So it's plenty of daylight, you would think, and also quite generous views out towards quite green spaces. It's very nice because, due to that. You can also see that there are internal blinds with manual controls for each window. What else can you see here? Well, you can't see, actually, it's not in the picture, but there is also external shading in the form of brise soleil on the south and west walls. So you have external shading. And on this layout, you can see the numbers 1 to 17. There are 17 workstations or desks in this space, and the occupants are basically using the chairs as they are marked, so they are all facing those ways. And the size of the space is about 120 square meters, with a ceiling height around 2.5, just to get a broader perspective of the space.
So it's slightly peripheral to the actual daylight. You can see the gloss on the work surfaces is probably 30 to 50%, when ideally it should be below 15. So is that anywhere within the standard?
No. There is no requirement specifically on direct reflectance. Yeah.
Significant irritation from the architects who want glossy surfaces, and you just get fading reflections.
Well, I think it may be covered in a way by the UGR values, if you do the modeling.
And it also comes into the gloss on the workstation screens that you really want the matte surfaces, because who specifies those is probably the IT people who don't know about daylight.
That's why you have to have this communication with the different teams in the project.
Anyway, suggestion that be included.
I think this may be also due to the contrast that you get in the picture, because to be honest, I work in that space and I've never been disturbed by that specular reflection.
You can in quite a number of offices.
You can
have glossy floors, so that corridor picture of the offices, the floor was fairly matte, but yet a glossy surface, some tiles, and it's very irritating to the eyes.
Yes, I agree. Can be specific for some directions of view. Yeah. Okay. First, we just did a very basic calculation of every daylight factor, just to see what the values would be. And by carrying out basic computer modeling with an empty space, so no furniture, no obstructions, just empty space, you get all these values: 5.6 ADF, minimum point daylight factor 1.8, and a uniformity ratio of 0.32. So if you just rely on these values and look at the daylighting criteria in the BREEAM International New Construction 2016, the space would meet those requirements. But then if you look at the in situ measurements, because you obviously went into the space and measured different things, as I'll say later, we also measured horizontal illuminances from daylight, and it was an overcast, it was a day with an overcast sky. So actually last Saturday, with that beautiful overcast sky, very dark, just before the snow started to fall. So it was really, really overcast. So I would take that as a positive for the measurements. So the ADF, which was measured, actually that's the average of the point daylight factors measured via obviously horizontal luminance and external horizontal luminance at all the 17 desks, was 1.9%. The minimum daylight factor was 0.6% at one of the desks, obviously, but the uniformity ratio remained the same, 0.32. So it was quite uniform, I believe, compared to if you look at the BREEAM daylighting criteria. Obviously, the drop in the values is normal because you get all the furniture in place. You also have some external obstructions like trees, and also there is an issue with the calculation grid in the computer model was different to the measurement locations inside the space. So there is some difference because of that. This is just to get an idea of what an ADF would be in this space. Or if you just rely on the modeling values, which it happens quite frequently, it will comply with BREEAM. But then if we go to the first feature in the Wellbeing standard that has references to daylight, it's feature 54, circadian lighting design. As we said earlier, you need 200 EML with daylight at least 75% of the desks in the space. Again, measured 1.2 meters above the floor, facing forward, and in a vertical plane. What we did, we measured on that day, we measured at all the desks, we measured the spectral power distribution of incident light, at that point, vertical plane, so just to match obviously the standard requirements, and also visual lux levels, so vertical illuminance. And then we worked out the EML values. And what we found was that at 1 p.m., 82% of the workplaces met the requirements, so had at least 200 EML. But at 9 o'clock in the morning, only 71% of the workplaces. I say only because it's below 75%, so it's just 4% difference, which basically means one more desk, and the requirements would have been met on that day with those particular conditions, with the electric lighting switched on, I should have mentioned. So it's both daylight and electric light.
So the light level outside was 6,456 lux. That's very, very overcast. It's a...
Yeah, I think snow was on the way.
Last week I was taking some readings on a very cloudy day. It was about 14,000 lux. So that's like kind of black.
Yeah, it was quite dark.
So that's the worst case scenario, really.
Which I think it was good because, you know, in this way you can show that it's March, it's mid-March, almost equinox state. And, you know, if on such a day to get these conditions, you may easily get similar conditions in December, you know, the winter solstice. And if the standard requires you have to have that, you know, you have to meet these values every day of the year, then, you know, there are worse conditions possible.
So is this about 4/5 electric light contribution?
Let me think. I would say 3/4, kind of. Yeah. But actually, that's a good point, because I should also mention that even if you look at the second criterion with 150 EML from electric lighting, you wouldn't meet that. It was, I can't remember the values, but you don't meet that. It's actually, no, it's 25% of the desks, yes, I remember, 25% of these desks in this space met 150 ml, the 150 ml criterion only from electric lighting. I should have mentioned, you may have seen in the picture, there are LED panels, a number of them. The average horizontal illuminance is roughly around 400 lux on the working plane. So if you divide that roughly by 2, you would get about 200 lux. And the spectrum, well, they are rated 4,000 Kelvin, but obviously the spectrum depends, you know, on what's happening in the space at each point, so that differs. Yeah, so that's about it. So in other words, that's this example of an office space on that particular day, those times met these values. This is another way of illustrating the findings. So graphically, you can see both conditions, 9 o'clock, 1 o'clock. And actually, the graphs here also show you the melanopic daylight equivalent illuminances and the circadian stimulus values for the same places, same points, just different values, because you have obviously different metrics. And the horizontal lines show you the targets that were recommended by the different schemes. So for example, if you look at EML, equivalent melanopic lux, at 9 o'clock, as I said, one more desk and the criterion would have been met. 9 o'clock, and 1 o'clock, 82% of them meet the criterion. So you have all these green points above the horizontal green line. If you look at MDEI in blue, so it's all shown in blue, you can see that not so many points are above the line, so it's more difficult to meet that. It's actually the most demanding criterion if you look at the numbers as well. And also circadian stimulus 0.3, it's somewhere in between, so it's not as hard as MDEI, but not as easy as EML. And another way of looking at the data is this. So if you plot EML and MDEI values, obviously you're speaking in absolute terms because the unit is different, against CS values at 9 o'clock and 1 o'clock, there are some interesting things here to note, apart from the fact that EML may be easier to meet than compared to the others. I mean, again, for this example. But what's worth looking at is taking these three perspectives. So the first perspective, if you look at the points that comply with, say, the CS criterion on the right-hand side. So to the right of the red line is CS above 0.3. You can see that those points also meet the EML criterion, so all the green points are above the green line, horizontal line, but not necessarily the MDEI criterion is being met, because you have some blue spots, blue points that are below the blue line. And that's the case for both 9 o'clock and 1 o'clock. Now, if we look at compliance with, say, EML, so all the values marked by the green points that are above the green horizontal line, you can see that all of them actually are already compliant with CS. Well, there is one right on the line, but you can say that's compliant. It's actually 0.3 exactly. But we can't say the same thing for MDEI values, because there are some values that are, I'm not sure if you can show, no, there's no point. There are some blue points that are below the blue horizontal line. So again, the MDEI criterion is more difficult to meet. And the last case was compliance with MDEI, isn't it? So if you look at those MDEI values that are above the horizontal line, they are already compliant with both CS and EML. So in other words, the conclusion, to this diagram here is that the MDEI criterion is the most demanding and the EML criterion is the least demanding. And if you go back to that link between EML and CS with D65, or being almost close at D65, I think those two metrics are closer together. MDI is slightly, too challenging in a way.
Is this a standard just for offices or for all types of buildings?
Sorry, which standard? The Wellbeing standard, or?
Well, yeah.
This example I'm showing is about offices, but there are other versions, other pilot versions for other types of building. Yes, but this is for offices. I'm talking to you about, yeah.
Forgive me, I'm just slightly, this is the worst possible winter's day when anyone in their right mind would be jumping in their car and getting home before the snow falls. And you're saying, yeah, it meets. But in order to meet it, you've got to actually have a room with windows on 3 sides, in which in most cases you're going to be boiled alive for most of the year.
Well, yes. That's why you would have to have shading as well.
You're not convincing me that this is a standard anyone's going to be meeting anytime soon.
I'm not trying to convince you of anything. I'm just showing you this example of an office space.
Just everybody, Cosmin is not responsible for that.
Yes. I'm just showing you the
when our
requirements.
sustainability officer starts making happy noises about should we be meeting the Well standard, just at the moment I'm screaming no.
Well, because you have also the other criteria that look at, minimizing glare and unwanted heat gains. I think if you would look at all of them together in a more holistic manner, it may help. And then if you look at these values to get them, obviously it's, the standard encourages, the use of daylight, as much as possible, but obviously you wouldn't want to create the unwanted impacts. And also you could use electric lighting in the right way to increase the, say in this case, EML values to the right ones. But again, I should point out that these recommendations are based on some values given in the standard. And as far as we are aware at BRE, you need more research to back up the values and maybe to come up with different values for different building types, different types of space, different applications, and so on and so forth. And actually, I should mention that we are doing a project at the moment on circadian lighting that looks exactly at these things. We just, in an office space, we are investigating different conditions of tunable LED lighting in this case, just to see, what light levels, what durations, what time of day, and what spectra to give the occupants to try and maximize the well-being and health and well-being benefits. So again, this is subject to ongoing research. I would definitely say that.
So not going to be first adopters.
Well, the well-being standard has been already adopted in a number of places, and it's
the next talk will be
exactly about that. So you'll see some nice examples of a space
So let's.
One
Yeah.
is for Surrey Lansing's offices
Yeah.
in Victoria, and the other is Hughes and Moran offices in Munster. But I know that they got the well accreditation.
Well, Hilton are on a third refurb, and I think you're
Lansing is also refurb.
yeah, and that's the point. No one would build a building from scratch like that with louvers that deep with 3 stories with windows on because it's just the cost. But they would, if you already are trying to sell well as a service, you would, assess your building that someone else built that doesn't have any of those big stuff. But louvers, any kind of louvers are hard to sell these days to try and get workers to run. So
I know our architects put them on and we value engineered them off immediately.
I'm very sorry, we're going to have to ask Cosmin to continue this talk. The coffee will be identical after a further 5 minutes. Thanks very much, everyone.
Right, so this feature here, solar ground control, very easy to check and meet. Blinds, manual control, all done, yes. This one, no. It's because of the way the screens are placed, oriented within the space. So you can see, I mean, if you just imagine the screens as they are on the desks where the numbers are marked, people sat on chairs looking at the screens. So basically the screens would form a 45 degrees angle perpendicular to the plane of the nearest window, which is more than 20, so this feature is not met. It's an optimization. This again, no, because there are no automatic controls for the blinds. It's all manual. It's very quick now. Right to light, feature 61, is, if you remember, about those maximum distances between windows or atria and desks. And you can see the dimensions of the space is not very big. So in this case, all of the desks are within 7.5 meters of view windows. So obviously it's a yes. Not very difficult, this one. This wasn't met on daylight modeling feature 62. By looking at the modeling results, spatial daylight autonomy was fine. So more than 55% of the office space had daylight illuminance of at least 300 lux for at least 50% of the working hours, but also more than 10% of that space had more than 1,000 lux over 250 hours in a year. So annual sunlight exposure criterion was not met. But then we also looked at the other alternative methods in LEED v4 for daylight credits, where you get that option to look at illuminance from daylight on a clear sky at the equinox at 9 o'clock and 3 o'clock. We calculated that illuminance, so basically that has to be within this range, 300 to 3,000 lux to comply with LEED v4. 9 o'clock was fine, but 70% of the area at 3 p.m., only 70% compared to 75% as LEED 4, the requirement in LEED v4 is, had an illuminance within this range from daylight on a clear sky, again, a clear sky day at the equinox. So this criterion was not met, and therefore the whole feature was not complied with. And this feature wasn't complied with either, just because of that red arrow there. There are window-to-wall ratios as measured on external elevations between 39 and 47%. That's within the recommended range, 20 to 60. There is external shading, as I mentioned earlier, on the walls with window-to-wall ratios above 40%. But because the window head height is at 2.24 meters from the floor, only 6% of the window area was at more than 2.1 meters above the floor, which is obviously much less than 40 to 60% as the well feature requires. So this wasn't met. It didn't help too much to add the visible transmitted data because the feature was not complied with already, but just for the sake of completeness, visible transmittance was above 0.5 and also pretty uniform over the visible light spectrum. This was this example of our office space. Yeah, it's one of our office buildings in Watford. I should have mentioned that. You can see actually from this picture here, it has some nice view out. There's a balcony where you can see, you can go out and you can see, like, you know, watch tennis games and things like that happening in summer mainly. But it's a nice place. I mean, as I said, generous views out, quite well daylit on most of the days. These LED panels that give you, I would say, adequate amount of daylight, electric light. But if you ask this question, would this project achieve WELL certification by only looking at the daylight requirements? The answer is that big red no. And the reason for that is that thing with circadian lighting design, feature 54, 9 o'clock, 17th of March, before snow, not enough equivalent nanopeak lux at least 75% of the workstations. Okay. Right, so this is the last slide. Conclusions. We've seen this example of the office space. We went through the various criteria, but it's, I think, important to highlight that, you know, this is a standard for buildings and interiors that actually takes forward the various strategies to think about or to focus on the health and well-being of occupants. You have this, tangible advice. This was just a presentation on light, but you have all the other concepts on air, food, air, nourishment, water, and so on. So it's a very complex thing. And just focusing on well light, so the concept, the light concept, we can conclude that whilst some features are easy to evaluate or to comply with, there are others also who, for example, circadian lighting design and daylight modeling, who require more complex protocols, modeling, testing, and it may not be very easy or to comply with or to verify, especially the in situ measurements. And for this reason, in practice, it may be difficult to comply with this, with the requirements of this standard or to verify them. But having said that, there is a second version of the standard that will be released at some point this year, which I believe, I don't know, but I believe will address some of the issues around the first version of the standard. So I think that's me done. Thank you very much.
Thank you.